Now, the form of the question from command words, we kind of mentioned this a bit yesterday, but I'll just recap this carefully for everyone. So these kind of words here, feel free to add these annotations in. These involve working. So there will be method marks. And if we don't see the method, you will lose marks. So these involve working. These questions that say give, state, or write down, these are usually worth 1 mark. Okay. And plot, sketch, and draw, obviously there's slight differences in what we do for each of those. But a sketch, we need to see the key features, the right shape. A plot is where you do like a table of values and dot to dot kind of draw it out. But the sketch is more the A-level skill. And so many people think sketch just means I'll just do a kind of whatever drawing, hasn't got to be to scale. It does still need to be an accurate representation of the curve, right shape, key features, asymptotes, turning points, intersections with axes. So arguably it's more involved than just plotting it without really thinking. And then the explain why, justify, give a reason, and comment on. These are normally follow-up questions in modeling questions and the applied maths. Brilliant. Right. Let's look at a few specific examples. So determine, show detailed reason, fully justify, etc. Working is required often if these are like bigger questions, and you have to kind of pretend the examiner doesn't know anything so that you actually get the marks. So imagine you're explaining it to a friend or something. Right, let's look at an actual question then. So the function f has a domain R, so all the real numbers, and it has a range that y is greater than e. So remember, the domain is for the x values, it's for the inputs, the range is for the y values. And there's a picture of the graph. It says the gradient of the curve at the point xy, so at a generic point, is given by its derivative, dy dx equals x minus 1 e to the x. Find an expression for f of x. Fully justify your answer. 8 marks. Now, arguably, that might be quite generous with marks, but let's go through this together. Just very quickly, I'm going to show you the mark scheme. We will go over these skills later because this is quite a big question, but we'll talk about how the marks are allocated here. So because you're given a derivative and you want the original function and you're told the range and the domain, we are going to need to use integration to go from the derivative to the original function. Now, for first thing in the morning, this is not like the easiest integral to do. So I'm going to just talk this through with you now. This is actually an integration by parts because you've got two different functions that aren't related to each other by their derivative. And this is definitely a big year 13 integration question. So it's by parts. They're not linked as a reverse chain. They've not given you a substitution. So you'd refer to the by parts formula in the formula book. And remember, we set one thing up to differentiate, one thing up to integrate. And so the first thing would be to differentiate x minus 1 and integrate e to the x, and then basically put that in the formula. And up to this stage, if it were out of 8 marks, you'd have 2 already. So you've correctly identified the technique, given the mark for subbing that in efficiently, and then let's keep going. So don't forget the constant of integration at the end once you've fully done it. Now, this is actually really important because there was no plus C in the actual answer. They wanted you to find the actual function. And for a lot of people, they might have thought, well, they didn't give me a point to sub in. They just gave me a picture of the graph. How can I do that? They kind of did give you a point to sub in because they gave you the minimum. They told you that the range was greater than E. So that means the Y value is E at the minimum. This is a really important problem solving aspect of this question that we could all overlook. This would be really easy for me to miss. We could all miss this quite easily. If I just take you back to the picture of the graph there, that was the most important bit, I would say, of the question. because that does give you a point. That tells you about the lowest point. If you've got a range defined, you're being told where the outputs are capped or where the minimum is. So we're kind of effectively being told this point. So that was what made this a little bit more involved. So if you know it's y at the minimum, the y value at the minimum is e, then we know minimum points, that should be crying out differentiation. That should be when the derivative is equal to 0. And remember, they started by giving us the derivative. So if we set x minus 1 e to the x equal to 0, there's only one solution to that. E to the x can never be equal to 0. So x must be 1. So now we actually have a coordinate that we can explicitly sub in. So this is the coordinate 1, comma e, x value 1, y value e. And again, we've picked up a couple more marks at putting that together. So I would say a mark for kind of identifying this, putting the plus c at that point, and then also getting to this stage here. Now, putting it all together, you've got the equation of the graph with the plus c. You've got an x and a y value to sub in. You can rearrange, and c is equal to 2e. And then basically simplify. Okay, and welcome to anyone else that's joined. We're just going through exam techniques, so please don't think that was a really quick go through of integration. We're going to do that all properly again, so don't worry. We're just looking at how like the marks are allocated for this. Brilliant. Okay, right, I'm going to push on to some more command words here. Right, show that. Let's look at this. So show that answer should be sufficiently detailed so that we can follow every step. So like, same for proof, show that and proof. Remember, the answer is given to you. So it's not about like racing towards the answer in as few steps as you can. It's actually almost about maximizing what you showcase, that you actually know how to get from there to there. The examiner knows the answer. We all know the answer. It's in front of us. This is all about method. So this is exactly the kind of question you can't just put into your calculator, because it would be pointless. It will hopefully just give you the answer you already know it should be. So that's a kind of key thing. You can't just put these ones into your calculator. We actually really need to think about the method. Okay, brilliant. So this is a very sort of, I would say, so common now that the questions start with a show that or a prove or a show that this equals to this. So really important. Now let's have a little look at actually this question here. So this show that question. Now you're given the sum, which your calculator can deal with, something like this. But again, it's just going to do it. So we need to think about breaking this up. Now your first mark will be from appreciating that you can split this into two summations. So hopefully we're all familiar with the sigma notation. Now what this is really important in identifying is this little first chunk is actually an arithmetic series, and this one is a geometric. So hopefully you've seen that before, but that will then point us towards the summation for for a series that's arithmetic and geometric. And I believe most of them are given in the formula book. I would just say, sorry, this should be R instead of D. I would prefer if we wrote that. You might want to amend that actually in your books, unless that is what it says. So remember, for a geometric, we'd have R. For an arithmetic, we'd have D. But it's the formula you're given or you should know from your formula book for your exam. And this is how we're going to show it explicitly. And the problem with these questions is they do feel tedious because we're actually putting numbers in, writing it all out long ways. But that is unfortunately what they want us to do. So you sub in A as 2, A as 8, and find the first term and find the common difference and the common ratio for those sequences and series there. And then you actually just spell it out with the numbers. So put the numbers in and it should equal what we expect. Okay, brilliant. So that's actually a good one to look at, because I think with the way the technology's progressed and the fact that we can do so much on the calculator now, we don't always make the link with the sigma notation that actually it is just partly an arithmetic and partly a geometric series just put together, which we can deal with if it just said do an arithmetic series. So let's keep going. Some more command words. So we've got explain why, justify, give a reason, comment on. So you'll have a question like this. And I mentioned this yesterday, I think, as well. The examiners have said that the national picture is people are weakest on these questions. And it's annoying because they're not always worth that many marks, but we sort of just throw them away. So you can imagine that this could be a mechanics question, and it will say, right at the last bit, explain the change in motion that the driver noticed. Okay, explain. So a lot of mathematicians do not like that word because they want to do maths. They don't want to start writing an essay. And it is just a short, snappy answer, but it needs to be clear and it needs to be correct, obviously, as well. And there's some funny answers for mechanics where people have just tried to write something and it doesn't make any sense. So what will the driver notice and why? So we really should describe everything that's happened. Let's go back to the question so that we're actually doing this properly. So a buggy is pulled, pulling a roller skater in a straight line along a horizontal road. The combined mass is that, driving force and the resistance are given. And so you do this whole question, find the acceleration. Then it says the roller skater releases the rope at point A and she reaches a speed of 6. She continues to move forward, experience the same resistance force. The driver notices a change of motion in the buggy and brings it to rest at a distance of 20 meters from A. Explain the change of motion the driver noticed. Right, let's think about what happened. So the rope's released, meaning the tension isn't there anymore on the buggy. There's no resistance, less resistance to the buggy because there's not someone dragging against it. So the higher resultant force on the buggy will mean there's more force forward. So the driver will actually notice an increase in acceleration, and that's why then the driver has decided to bring it to rest. Okay, so the bringing it to rest, people might think, oh, the driver slows down because she let go. That is not the case at all. The driver's chosen to do that because the buggy's actually sped up. Okay, so do try and think physically what would happen. Right, so there would have been your 2 marks for, I would say, this stage here, mentioning the tension, and then the correct conclusion. Okay, brilliant. Right, let's get on to the plotting ones and look at what we're expecting here. So we spoke a little bit yesterday about sketches, but plots are more accurate using a table of values. Now, it's fantastic that the calculators can help you out, some more than others, with this, but it's the key features you want to preserve and represent and show the examiner. So if, for example, it says sketch the graph of y equals modulus 2x plus a, where a is a positive constant, again, you can use your calculator a bit to help you, but I would say bear in mind, the examiners know what your calculators are capable of, so they'll often put an algebraic unknown in the actual graph you've got to sketch, which will make it hard to use. Now, you could still just choose a number and try it out, but this is a sketch, so we want to see the right shape. So the key thing to note is you can sketch this on a graphical calculator and maybe give, oops, sorry, what happened there? Is that still sharing? Yep, okay. Oh no, it's gone a bit weird. Let me sort myself out here. Apologies for that. Can we all see this again? Yes, okay. So you can sketch, oh no. Something keeps happening. I'm going to just stop this for a minute, guys. Apologies. We're right in the flow of things there. Yeah, as I said, this will be possible on your calculator. And if you've got a calculator that does this, try it out right now, but maybe put a number in for A. So choose this and check that you can do it, because this might help you immediately do the sketch. So let me just resume sharing screen. And we'll try and do this together. So something very odd is happening with the pen. And I'm going to try and fix that in 1 minute. Apologies, guys. So just checking we're all on that same page. I'm going to push this on shortly. Let me just reshare it again so we've all got access. Here we go. And we'll have a little look. So moving this forward, let's look at the following. So what we would have here, 1 mark for the positive shape, and this actually ties in with graph transformations. So whereas y equals 2x plus a in the modulus, because it's in the function, it moves the opposite way in x. So it's going to move across. Now, what you'd have is the 1 mark for the shape, 1 mark for the y-intercept to a, maybe add that on. I would do that, but I don't want to mess it up for a minute. So I'm going to let you just fill that in. The y-intercept up at 0a, and the x-intercept is actually going to be at minus a over 2. And remember, the way to solve that is set the y value as 0, rearrange and solve. And there'd be 1 mark for that as well.